Version control is something that every programmer uses daily to collaborate with other people. And if you're new to programming or want to find a job in the tech industry, perhaps as a software developer, then knowing how to use Git is going to be an essential skill for you. Using a version control system is pretty much one of the first things that you learn as a developer. And Git is one of the many version control systems out there that you can use to collaborate on projects. I will show you how you can use Git to share your coding projects on GitHub, build your portfolio, and showcase this to potential employers. Even if you're not a programmer or not looking for a job in the tech sector, this session, I hope, will give you some insights on how software developers work together at the same time on software projects. So my name is Christiana, and I work at Templify as a software engineer. And prior to that, I studied computer science at Kia. And I'm originally from Romania, have been living in Copenhagen for the last 6.5 years. And both professionally and as part of my studies, I used Git to work with my colleagues on different coding projects. So I'd like to really describe the problem or the need for version control. So while I was studying at Kia, we had this assignment of building a social media app. And I was working with 2 other classmates. And imagine one of us would work on creating the like button feature, someone else would do the comments section, and another colleague would maybe work on the backend or colors. So we wanted to work at the same time and in the end, merge everyone's changes into the final product. So you could try to send these files from each one of us over Messenger or email, and then manually try to combine the changes. And the more people you are, this becomes harder and this becomes impossible, right? So version control and other tools I'll be talking about today really enable collaborating on coding projects. So what we did was we shared code on GitHub. And GitHub is a hosting service for Git repositories. And I'll explain what a Git repo is, but for now, think of GitHub as a place or a site where we upload code. And we use a tool called Git to do just that. We were able then to add changes and see when someone else modified the code, see what lines of code each person added. And what exactly is version control with Git? So let's explain those terms. So version control, also known as source control, is a practice of tracking and managing changes to source code. So if you think of software as a book, then source code would be the sentences and paragraphs, chapters that make up this book. And in this analogy, it means that we can track if any sentences were added or removed, if paragraphs were revised, and we can add a whole new chapter and so on. All of these, while you keep a history of each state of that book, each version of that book. So imagine you made revisions and at the end of every day, you would save or you would commit the contents of that book as a new version. So after a working week, you would have 5 different versions of that book. And in this analogy, Git is sort of like your librarian that stores each book version and gives you any book when you ask for it. And Git is a distributed version control system. So that is, I'll explain what distributed means later in this presentation. But some of the alternatives to Git are Mercurial or Subversion. But by far, Git is one of the most popular ones, and many companies use it And I think most open source projects are hosted on GitHub. All right, so now that you know maybe what version control is and what Git is, why learn it? Why should you care about this? Well, learning how to use version control will definitely help you build a portfolio by putting different coding projects on GitHub. And you can then showcase that to different employers. You can even contribute to open source projects. And ultimately, learning Git, you gain a skill that is needed for a daily workflow of a programmer. The main reason, though, that I think it's important that you know Git is that you can then collaborate with other people. So different teammates would be able to work at the same time on source code. And finally, history. So even if you're not working with a team, just having a working version of your code at all times and see what has changed between versions, that's going to give a lot of confidence that no matter what happens, you always have something working. And you can revert to a previous version if needed. This next section is all about the words used when working with Git. And don't worry, if you don't remember all of them, it will make sense in practice, I promise. So I talked a bit about a repository. This is what stores all the versions of your project history. And in a practical sense, your repository is in a hidden .git folder on your computer. In the analogy with the book, your repository would be sort of like the library itself, right? Then there's a commit, which is sort of a unit in our version control. It's a set of changes. You can think of it as a version of your project. A commit will have a unique identifier, an author, timestamp, and a message. You really want to give it a good, meaningful message because this is what's going to appear in your history. So when you look back at what was changed, you want that message to really reflect those changes. Then we have the concept of a branch, which is really a string of consecutive commits, chronological, right? And in a project, you can have a lot of branches. There's a convention that your initial or first branch is called a main or master. And typically that's where you have all the stable versions of your project. And in a workflow, you would normally have different people working on features in parallel, and perhaps one person might do a bug fix. So once they finish that work, once they add some commits and are done with that, then they would like to merge that into usually the main branch. And a pull request is request to merge changes. This is when you typically have peers or colleagues review what was changed and perhaps even add some comments and figure out, okay, what do we want to do with this? Perhaps add more changes. And when everything is approved, then you do the merge and you create a new commit containing all the changes, both on the main branch and on the bug fix branch. So I promised I would explain what distributed version control meant. So as opposed to a centralized version control where you have a single repository going on, in a distributed version control, you have a lot of clones of the same repository. So in this scenario, imagine you have a repository on GitHub, which is hosted in the cloud. And then every collaborator, for example, my computer, Oksana's computer, Ellie's, and so on, they have a clone or a copy of that repository where they make changes. And then the arrows in this diagram symbolize how you need to then sync with the repository, from the local to the remote. And that leads me to the next slide. So a remote repository is typically the one on a hosting service, and it's used for syncing changes. So it's the shared one. And a local repository is the one where you want to make the changes. And it's on your computer, usually. And the arrows also have names. So push is also an operation. To push means to upload content from your local repository to a remote one. Pull is when you download from a remote and merge the changes into your local repository. And fetch is checking if there's any changes on the remote repository. So hopefully now that you have an idea of the words used with Git, how does it actually work? So in the diagram previously, you saw that there was a lot of repositories, but it has to start somewhere. So you can either create a repository on your computer and push it onto GitHub, or you can create it on GitHub and clone it onto your computer. There are also some commands that you can run in a terminal to achieve this. You don't necessarily have to use a terminal. You can definitely use a visual tool like GitHub Desktop. I will show you how you can do that later. But I put the commands just in case you want to use the slides and reference them later. So once you have a repository on GitHub and the repository on your computer, you can start a workflow. This is the most common workflow. So first, you want to pull changes from GitHub onto your computer so that you have the latest version of your code. Then you want to make some changes, perhaps add some files, add some lines of code, and you can create commits from those changes. And then you want to push those onto GitHub so other people have access to your changes. And this is sort of the commands used to achieve that. 80% of the time when you use Git, use these commands. So how does a collaboration workflow look like? First, you start with the workflow where you pull the changes from GitHub. You guessed it, you create some commits, and then you push those onto GitHub. So now let's say Oksana wants to collaborate with me. She would then get my changes, add her own, and then push those onto GitHub. So what happens if you forget to pull? So we're in this scenario where I've created some changes, some commits. I push them onto GitHub, and Oksana has created her own changes as well. And really, this is like the best way that you're supposed to even use Git and version control. This is the whole point, right? We're working at the same time and creating commits, and it's totally fine. But if she tries to push, it says, okay, rejected. You have to actually pull first. No problem. So you can pull, and then you get merge conflicts if you edit some of the same files. Then sometimes Git doesn't know how to automatically merge these. So in that case, you have to merge those conflicts. So then you would create a new commit, which has both your changes and Oksana's changes, and then push. So now it's on GitHub. So let's see it in practice. Maybe, are there any questions so far? If not, we can also take them at the end. So the first thing that I want to show is really how to set everything up. So you need to go to github.com and sign up and create an account. So once you have that, you'll pretty much get something like this. This is your dashboard on GitHub. And you can see a lot of the repositories that you are working on or contributing to, recent activity from the community, and the different repositories that you can explore based on topics that you might be interested in. And you can definitely set those here in the Explore tab. Then there is the pull request option. I'm just going to give you an overview of what you see on GitHub. So in the pull request, you see any work that needs merging, whether you're contributing to a project or whether there's contributors to your open source project. And then you can see issues. You can think of issues as a to-do list. Basically, in each open source project, you may have bug reports, feature requests, and so on. And you can pick items to work on from here. Marketplace is just somewhere you can find integrations to GitHub. For example, if you want to connect your code to a pipeline and deploy it somewhere in production, probably find some good extensions here. But what I want to really show today is, how you can make GitHub your portfolio. So you can update your profile here. And of course, after you create some repositories or make some contributions here, you can then put different projects. And you can, of course, make your small bio here. You can see what repositories I contribute to, for example. And this can act as something that you send to hiring managers. They might look at this. And it definitely showcases different technologies that I'm interested in and repositories that I have worked on. All right, so how do you add a repository? Well, you can go up here and on the plus button, select a new repository. And this is the first step. So in the demo today, I would like you to focus more on the Git practices and version control and not so much on like a programming language. So we're just going to create a book, and then it's going to have different chapters and different paragraphs, and it's all text-based. So the repository name is just going to be book. And this name and description is what would be visible on your profile, so on your portfolio, if you will. So if it's an open source project and if you want to showcase it, you have to make it public. But if you're in a company or you just are working on some private project and you don't want this to be visible, you mark it as private. And I could just skip the next step here and create a repository, but I want to go through each option here. So if I add a README file, it even says is where you add a long description about your project, especially if it's something like open source project. You really want to describe, okay, if you're creating a library, how do you use this, or what is it good for? So all repositories should have a good README file. If I check this, that will already create the main branch for me. And then we're in the scenario where we create the repository on GitHub and then we clone it to our computer. If I don't want to do this, then I would have to initialize the repository on my computer and push it to GitHub. So for now, I just want to create it on GitHub. So I want to add a README file. The next option here is the git ignore. Since we're just making a text-based project, we don't need this, but really depending on the language you're using, there's a lot of useful templates. So, for example, there's something for C++ or Node or Python. You really want to choose this based on the project that you're making. And then the license, this is definitely relevant if you're having a public repository. So it tells people what they can do with your code, if they can just copy it or what. Most open source projects, I think, have the MIT license. Cool. For now, I'm not going to do any of those. I'm just creating a README. Create repository. So in order to actually put or make changes and put code here, I need to have some tools installed. So because I've already installed these tools, I'm going to show a video about that. So the first thing you want to do is install Git. And to do that, you go to git-scm.com, choose the platform, and then install. I'm installing for Windows in this case. You can pretty much go with the default settings here. I'm just setting Visual Studio Code as Git's default editor, but you don't have to do that. Just go with the default. That's going to work fine. So once you have installed Git, that should actually be enough to work with Git, but it would allow you to write commands in the terminal. So I really want to show that you can use version control with Git without the terminal, especially if you're a beginner. I think it's very useful to visualize what's going on. And that's why I recommend installing GitHub Desktop. This also has the added benefit that it integrates with GitHub. So to do that, go to desktop.github.com. You want to download that and install. And I mentioned that you can integrate with GitHub. So you do that by going to File and Options, and under Account, you can sign in to GitHub. You can continue with the browser. And you should be able to connect. So once you do that, you'll see all the repositories that you have access to in GitHub Desktop. And then you can clone any of them. And it would then allow you to choose a local path. So where on your computer you want to clone the repository. One more thing I want to show here regarding to setup is that if you go to File and Options under the Git tab, you can set your name and email, and these will be added to the commits you create as part of the author property of the commit. So once you have these tools set up, you're ready to go. I've just created this repository. So what I can do is either clone it using the terminal and then using this address to do so, or opening it with GitHub Desktop. I'm just going to keep it simple, open it in GitHub Desktop like that. And it's going to ask me, okay, where do you want to clone this? This is perfect. Just going to clone it into my GitHub book folder. So what I can do now is that I can open this in the Explorer. So as you can see, I have this README file that was added by GitHub. And this is the actual repository, right? The hidden.git. So if you don't see this, it's probably because you need to enable or make hidden folders visible. I can also open this in Visual Studio Code. And this is my editor of preference. You can use anything you want. All right, and let's make some changes. There's various ways that you can commit once you make the changes, and I'll show you 3 different ways. So let's add, because this repository is a book, let's add the file structure here. So we're going to make a folder that is going to hold chapter 1. So each chapter will have a folder, and then each paragraph will have a file. Let's add some random generated paragraphs. Let's add another one. Put that in chapter 1. Cool. So now we have some changes. So if you go to a GitHub desktop, you can visually see what changed. This README file was changed. So this line that didn't have a new line at the end of the file now has this new line. So with minus, you can see every line that was removed, and with plus, every line that was added. So let's commit this. You can select which files you want to add to the commit. This is called sort of the staging phase, if you will. So I'm staging the README file. And GitHub Desktop already recommends a message for this. So let's just commit that. So now I can see that the README file disappeared. This is because now it's in the version control and I can see it in the history. So I can see this commit with the README and exactly what changed. And I can also see that this commit is not yet pushed to the remote repository. And here I can see I have one commit that is not pushed to the remote repository. And what that means is that I only have these commits locally. If I go to GitHub, and if I look at the commit history, I can only see this initial commit made by GitHub when I created the README file. So if I refresh here, I don't see anything. But if I push to origin, this will synchronize my local version of the history with the one on GitHub. So if I refresh here, now I can see that commit that I just added. So let's add more commits. And this time, let's use a different method. So I still have these 2 files that I have added. So if you want to look like a hacker, this is what you do. Use the terminal. So there's different places you can use the terminal from. One of the ways is that if you go to the root of your repository, that's where you have your Git file, then you can select this Git bash option here, which is what you get when you install Git. And that opens terminal. Let me just make it a bit bigger. So it shows me the repository location and the branch that I am on. And then I can write git status, and I can see, okay, so the folder chapter 1 has changed. So what I can do is stage, meaning I add all the files. And this is just staging them for the commit. This doesn't actually commit them, doesn't put them in history yet. So now if I could do git status, now I can see that, okay, the paragraph 1 and paragraph 2 files were staged. So now I can add them. I mean, I can commit them. So let's add a message. So if I write git status, I shouldn't see any changes anymore because it's in history. And to see the history, I can do git log. And this is going to show me all the commits, starting from the latest one on the top. And as you can see, this shows me that, okay, this is where my local history is. So this commit is only on my computer. And this is the latest commit on Origin. Origin is the remote repository on GitHub. And actually that's true because I haven't pushed anything yet. If I go to GitHub, I can only see these two. Even if I refresh, there's nothing new. So to get it on GitHub, I have to push. So I can do git push. So now if I refresh, I should see the changes in GitHub. There it is. And I can even see the code here. So now I've added, some changes, and I've added this folder, and it's all visible. It's there on GitHub. And I mean, a lot of software developers like to use the terminal. It really makes us look like hackers, and it's awesome and it's fast. But definitely when you get started, you don't have to do it. But one way to get more comfortable with the terminal is to use the Git help option. So for example, I can write git help and any command, for example, commit. And that's actually going to bring up the documentation. Of course, you can also Google these things, but I just thought it would be cool to share with you. So it just tells me information about this command and different like arguments that I can use. And there's a lot of description here. So each option, what it does. So if you go to here, M, this is one of the arguments I used. It's used to give a message to the commit. So you can read about each command and what it does. Right. So you've seen how to commit using the terminal now. There's a third way to commit, and that is through your editor. So let's say we make some more changes here. Let's remove some lines. Let's add some more changes. So I'm using Visual Studio Code, but I'm sure other editors also have version control option. So if you select Source Control tab here in Visual Studio Code, you can see the changes. And then you can select this file and see exactly what was removed and what was added instead. So very similarly to using the terminal or using GitHub desktop, you first stage the change and make it ready for the commit, then add a message, meaningful message. This is what's going to be visible in history, and then you can commit either by going to the menu here, commit, or just pressing this icon. Again, I have the changes locally, so if I want to see them on GitHub, I have to push. I can also do that through the editor here, this menu, and push. So now if I go to GitHub, if I look at the commits, let's just refresh. Oh yeah, it was there. So I've shown how you can commit in 3 different ways. So through the terminal, GitHub desktop, and through your code editor. All right, so what happens if you want to collaborate with someone? Because so far it's really been the workflow where I just commit and push. No need to pull, because at this point, I know that there's no one else collaborating on this, so there's no way new changes could appear on GitHub. So let's say I want to collaborate. First thing is to give access. So you can do that by going to Settings, Manage Access. And then I can add a collaborator. So I'll just invite Claudia, and she's going to collaborate with me. So right now it's pending invite. She has to accept the invitation. And from here on, Claudia will show how that works. So
Yes.
I'll just stop sharing.
And I'm going to start sharing with you. And just so everybody has full disclosure, I am very new. I'm a baby to this, so I'm going to go a lot slower than Christiana has. But here's the invitation that was sent to me. So I can double click it here. And I can accept. And here is everything. And I can, like Christiana shown, open it with Git Desktop. And I'm going to clone it. And it's here, so I can open it. I also have the same editor. I have Visual Studio Code. And here it is. So I'm going to make some changes. Perfect. So now these are all my changes that I have made. So now I'm going to try to follow what Christiana has shown us and try to commit and push these changes. So I'm going to just quickly go back to my editor. And
remember to save.
Oh, yes. Now it should be there. Yes, and here we can see all of my changes that I have made. So they're all here, and I can commit them, and I can push them. So now they are in history. So I think from here, Christiana, you take over again?
Yes, so what happens right now if I want to work at the same time, and maybe I made some changes on paragraph 1, and while Claudia was showing you, I also wrote something in the same file. One moment. So Claudia edited this file, and I haven't pulled the changes. And that's intentional. I want to demonstrate what would happen if we got merge conflicts. So normally I could just pull, let's say if I edit another file here, I made some changes. All right. So I wrote here in paragraph 1, hello, this is Christiana. So I'm just going to commit them. I have not pulled, so my history looks like this. Okay. Okay, so now if I want to push, let's see what happens. Oh no, I cannot push because I need to pull first. Okay, so let's do that. Let's pull. And it tells me, oh no, there are merge conflicts. Resolve them before committing. So we'll do that. And the cool thing is we can see what was changed. So I changed paragraph 2, by the way, as well, but that did not have merge conflicts. It's only this one because this file was changed by both Claudia and me. And you can accept your local change. So in this case, this would be my current change where I wrote, hello, this is Christiana. Or I can accept the incoming one, so what Claudia made, or I can accept both. And I could even modify it like this. And then I can create a new commit that contains both our changes. So I'm just going to commit. Come on. Stage, and then commit. So now I can push the commit that merged. And if we go back to GitHub, we should be able to see all of our changes. So Claudia's change, my change, and the commit that merged both of our changes. Okay, so that was the demo. If I manage to go back to my presentation, that would be great. So today I showed how programmers use version control to manage different changes and collaborate. You saw how you can use GitHub to publish code, create a portfolio. We created a shared repository where Claudia and I added different commits and we merged our changes. Of course, this was just an introduction, just the tip of the iceberg, if you will. There's so many more resources out there. Of course, do check Git documentation. That is going to give you in-depth information about each command that you can use in the terminal. But there's also some good reading on Atlassian side. They have great tutorials for beginners. And then finally, do check video courses on Git if you're more of a person that likes videos. They're really good. They have a lot of tips on how to be productive with Git. Thank you.